So we're going to be talking more about variation today in 5.1 day 2. We're going to identify different types of variation from data and some more solving real world problems and some more mental math. So if you weren't here yesterday, we did talk about how this section is a no calculator section, and we dusted off some of our skills that we learned probably when you guys were at Murphy and Raleigh, right? The multiplying. Do you guys remember when you multiplied with decimals? What grade you were in? I distinctly remember doing my multiplication facts in 3rd grade.
Oh, yeah.
So I have to imagine maybe the 3-digit numbers or 4th grade. So we talked about 3 different types of variation yesterday, and there's one other type we're going to talk about today, but it's really just a combination of variations we've already done. Okay, so you guys wrote this down, you guys told me what they were, make sure you have the equation. You don't have to write this note, I'm just saying that when you have joint variation, you need 3 variables. That's how it's different than the direct variation. Okay, so the direct variation is only going to relate x and y, and for joint variation, you're going to have a 3rd variable there, the z. All right, and then for our first example, we're going to talk about how you can decide if a table shows direct variation and inverse variation, because the example asks us to determine if it's direct, inverse, or neither. So we're going to keep these in mind, and it's actually going to be similar to what we did earlier with tables. Okay, so, this would say direct, not direction. So direct variation, inverse, or it could be neither, okay? All right, so how can you decide if it shows direct variation? So remember, the direct variation equation is y equals kx. So if we were to solve this for k, we would have to divide both sides by x. That's kind of scrunched in there. So you would need to have this, k equals y over x. Okay, and then what has to happen is the ratios need to be constant. Okay, so all of the k values would have to be the same, and the ratio is going to be y over x. So I'm just going to put this out here, label it as direct variation. That's what we're going to use. Okay, and then for the inverse variation, we have y equals k over x. So if I wanted to solve that for k, what would I have to do to both sides? Yeah, so if I multiply both sides by x, I would get xy equals k. Okay, so in this case, the products need to be constant. So if you have a table, what you would want to do is x times y. If those are constant, then you have inverse. Variation. Okay, so in both cases, it's the k has to be the same. And this is the part that's going to look similar to what we've done in the past with tables. Okay, so for A, I'm going to give you the values, and then we're going to do our checks. All right, so we have 6.58 4, 104, and 0.5. Now it doesn't matter which one you check first. Okay, no matter which one you do, you just have to show your work for that. So we're going to check and we're going to see if it's direct. If it's direct, y divided by x should be the same for all of these. Okay, so that means 8 over 6.5 would be equal to 4 over 13, and that would be equal to 0.5 over 104. Okay, so what we're going to do is we're going to reduce the fractions. 4 over 13 is already reduced. If you have a decimal in a fraction, do you guys remember how to change a decimal like this? If there's 0.5 in it, what do you do?
Multiply by 2.
Yeah, multiply by 2 over 2. So 8 times 2 is 16. 6.5 times 2 is 13. Is that equal to 4 over 13? Definitely not. Okay, so we know that that's not going to work. Okay, you could do the same thing to this one, but you wouldn't even have to go further, but that would be 1 over 208, right? So they're not equal, so is it direct? No. Ratios are not equal. Okay, and then when you're doing this on your homework, you can just show your work here. Okay, this is to help you when you're doing this so that you can see, all right, this is why the answer was no for that. Okay, so then for the inverse, if it's inverse variation, all of the products will be constant. So 8 times 6.5, 13 times 4, 104 times 0.5. Okay, so we're doing this without a calculator. Yesterday, we came up with a lot of great strategies, right? So 104 times 0.5 is just 104 times a half. You just cut this in half. What's half of 100? 50. Half of 4 is 2, so put them together, 52. Okay, for 13 times 4, this is what I would do. I would break this up. 13 is made of 10 and 3, right? So we know 10 times 4 is 40. We know 3 times 4 is 12. So that's going to make 52. See how I'm breaking it up to make this easier in my head? You don't have to do it in your head. You could write out 13 times 4. Okay, and then remember how we break this up? We do 8 times what first? Yeah, which is 48, and then 8 times a half is, yep. Yay. Okay, so is this going to be inverse? Yes. Okay, and then we're going to write the equation when you have that. And since the product is constant, the data shows inverse variation. Okay, so we're going to say inverse variation. And then we're going to write the equation. So it would be y equals whatever you get here, the constant. Remember, you're finding k. So inverse is y equals k over x. So this would be 52 over x. So I do want you to put the equation in your final answer. All right, so I'm going to let you guys try the next one. We have 5 and 30, 848, 1272. Okay, so you do need to show your work for whichever one you choose. Whichever one it is, remember, you got to write the equation. And you can also choose which one to start with. So if you thought it was an inverse and you wanted to try that first, you could. All right, so let's set this up. So I'm gonna check to see if it's direct first. Just remember, when you set it up, it's always y over x. This is kind of similar to checking for what type of functions. What's a type of function where we had to find the ratios? Yeah, the exponential. The quadratic was the differences. Yep. So 30. What's 30 divided by 5? 6. 48 divided by 8. 6. 72 divided by 12. Yay. Okay, so this is our k value. So this is direct variation. All right, and then our equation is y equals 6x. Okay, great. All right, and then the last one is 3, 5, 6, 14, 8, 21. And I always like to check for the direct first. So I have 5 over 3, 14 over 6, 21 over 8. Okay, and then 14 over 6, let's reduce that. What goes into both 14 and 6? 2. So if I divide by 2, I'm going to get 7 over 3. This is 5 over 3. Are those equal? Nope. So I automatically know that it can't be direct. So now I'm going to check to see if it is an inverse relation. So then the products would be the same. And we know 3 times 5 is 15. Is 6 times 14 going to be 15? Obviously not, right? Because we could do 6 times 10, which is, what's 6 times 10? 60. 6 times 4 is 24. So this would be 84. Those won't work. Okay? Once you know that it's not equal, it's okay if you don't do the last one. All right? So then what's our answer for this? Nope. So this one is only asking if it's direct, inverse, or neither. So this one will be neither. And if it's neither, you do not have to write an equation because you don't have an equation to write. All right, now we're gonna talk more story problems, and whenever you have the story problems, you need to make sure that you label the units. Okay, we'll be talking about different units today. Some you might recognize from your science classes. You guys talk about energy. Yeah? Do you guys know what energy is measured in? Yeah, okay, so we have some joules today. Sounds so fancy. All right, so again, I'm just going to write this reminder that we do want to make sure we label our units. Okay, and then I like to use my highlighter because I know I'm going to look for a variation equation. So the time t needed to complete a certain race varies inversely as the runner's average speed s. So the first thing I do is I look at these variables. So t varies inversely as the runner's average speed s. Okay, so from that alone, can you guys write what the equation is here? Up top there. Rashawn, what are you thinking? What's our equation? Good, okay, so t equals k over s, so that's going to be our inverse equation. So we want to write that variation equation first, and then we are going to be given information that helps us solve for k. That's the variation constant. So this says if a runner with an average speed of 8.82 miles an hour completes the race in 2.97 hours, what is the average average speed of a runner that completes the race in 3.5 hours. So this says, what is the average speed? They complete it in 3.5. So you're always going to be given two sets. One set is going to have two variables. The other set is going to be something that you have to find and something is given. So you always want to use this given set. So this is the speed. So you're going to plug that in for S. Okay, so 8.82. And then in 2.97 hours, that is going to be your time. So this is your time. This is your S. Okay, so a couple people weren't here yesterday, so they missed out on the fun with decimals. So we gotta show them how we do it. So what do we do to both sides? Multiply. Okay, and then just FYI, because I know some of you are probably a little worried. On your quiz, if you have something like this where you're multiplying decimals, it would be an extra credit question. Okay, most of what's on your quiz is going to be simplifying fractions that we talked about without the calculator. Okay, so let's remember how to multiply some decimals. You ready? Let's write it up here. 8.82, 2.97. Do you guys remember what to do with decimals when you're multiplying? First step? That is in division. Multiplying is different. You move it to the side, and then you have to keep track of how many places you move it. So this decimal we move 1, 2 places. This decimal we move 1, 2 places for a total of 4. And the reason why I keep track of that is when we're done, you have to move them back. Okay, so this will probably be the most tedious thing we have to do today. So we're going to multiply. 7 times 2 is 14. Carry the 1. Do you think you can finish the first row without me? So we did 14, carry the 1. 8 times 7 is 56. So plus 1 would be... and then 8 times 7 is 56, plus 5 is 61. And then do you guys remember what you have to do second row? Yeah, good. Okay, so then 9 times 2 is 18. Carry the 1. Yeah, 72 plus 1 is 73. So we carry the 7 here. So this would be 72 plus 7, which would be 79. Again, I just want to let you know this type of problem would be an extra credit question, not something that you would have to do out. And then the last row, what do you have to do? Yeah. So 2 times 2 is 4, 2 times 8 is 16, carry the 1, 17, then we just add straight down. So 4, 7 and 8 is 15, 2 and 3 is 5, 5 and 4 is 9, 15 and 6 would be 21, 14, 15, 16, and then because we moved 4 places, I'm just going to go back. 1, 2, 3, 4. We're going to round to the nearest 10th. Yay, we did it. Alright, so let's write our equation. So the t equals 26.2 over s. Okay, great job. So Now, for step 2, it says to find the average speed of a runner who completes the race in 3.5 hours. Okay, so step 2 is find S when the time is 3.5. So if I plug this in, 3.5 equals 26.2 over S. What do you guys think your first step would be? How would you solve it? Yeah, you can multiply S by both sides, absolutely. Because you always multiply by the denominator, so don't multiply by the numerator. So yes, you can multiply each side by S, and then you divide both sides by 3.5. If you guys remember from geometry when you guys did proportions, you could also set up the proportion like this and cross multiply, but it's the same exact thing. Okay, so if you do have the inverse, you can set up a proportion.
If you multiply by the reciprocal,
Yes. If you multiply by the reciprocal, are you thinking S over 26.2?
no, 1 over 26.2 times 3.5.
Oh, so then you'd have 1 over S. So you want to definitely multiply by S or S over 26.2, if that's what you did. But you want to get that S out of the denominator. I thought you'd like the cross multiplying because you could just multiply 3.5 times S like that, and then since it's just times 1. But either way, you'll end up dividing these two guys. Alright, so let's talk about, you could set up long division, but let's talk about another strategy, okay? So remember yesterday we talked about decimals. We said if they're 0.5, you just want to double it, but this one isn't 0.5. So do you guys remember the other thing you could do? What moves the decimal place? Multiplied by what number? 10. So let's just multiply by 10 over 10. Because don't you guys think simplifying fractions is a little easier than doing the long division? Yeah. And then we can just ask ourselves, how many times does 35 go into 262? So let's try to estimate. So how many times does 35 go into 100 about? Yeah, 2 times. Like it's close to 3 times, right? So, and this is 262. So we would definitely say it goes into 262 6 times, right? I think it goes in there 6 or 7. Should we try the 6 first and see what we get? So this would be 30. 18 plus 3 would be 210. So yeah, you can definitely fit 35 in there again. Could you fit 35 into, could you add another 35 and still be lower than 262? No. Okay, so it is going to be 7 times. So it goes in there 7 times. How many would be left over? How would I find it? Yeah, you just subtract. And really, when I'm subtracting numbers like this, sometimes I just add up. What would you add to 45 to get to 60? Yeah, 15, and then plus 2 would be 17. Okay, so then there'd be 17 left over, right? So 17 and 35. Do you guys know approximately what the percentage is? Yeah, it's about a half, because 17 is half of what? 34. So this is going to be approximately 7.5. And then we have to put our units on it. So we're finding the speed. What's the unit for the speed? Yeah. And I'd be fine if you left it as a mixed number. I just want you to think about some of those things. These are good strategies for your SAT, PSAT, when you're trying to eliminate answers, right? Recognize that it's going to be half. All right, now example 3 is a little bit different, so I'm going to give you a minute to read it, and then if you guys can highlight or underline similar to what I did here, I want you to think about how you're going to set up the equation. At least start the equation, and then I'll help you with it, okay? So see if you can put what your equation is going to start with, okay? So what variable is going to be equal to the rest? I just want to do the equation first without the line. Oh. All right, so what was different about the words here? How is this different from all the rest of them that we've done? Yeah, there's 2 types of variation within one, okay? This is called combined variation. So it's when you have multiple types of variation. So it starts with the change in temperature T, and it says that varies inversely as the mass m. So what I liked is some of you were like, okay, I know how to set that up, right? I know T is going to equal K over m. So that's great. That's a great first step. Now it says, and directly. So the temperature T varies inversely as its mass m, and directly as the amount of heat energy E. So if it's direct, remember direct, you multiply by K. So this is just going to be multiplied by E. So if you cover this up, this is the direct variation. You cover up the E, you have the inverse variation. So it's 2 for the price of 1 here. Okay, so you have the direct on top, the inverse on the bottom. All right, and then your first step is always solving to find K. You got to find what that constant is. All right, so let's see what information they give us. They say that the temperature of an aluminum wire with a mass of 0.1 kilograms rises 5 degrees Celsius when 450 joules of heat energy is transferred to it. So that is the information we need to find K. So for the mass, I'm going to plug in 0.1. For the temperature, I'm going to plug in 5. And the joules is going to be what variable? What variable is it going to be though? E. Yeah. All right, so let's plug it in. 5 equals K times 450 divided by 0.1. All right, based on what you guys told me earlier, I feel like we know the first step. You guys want to tell me? Yep. I'm going to write this in 2 steps just so you can see that first, and then now you can see the multiplication. And then I feel sometimes it's problems like these where we second guess ourselves what it is. But remember, when you're multiplying, you move the decimal over. So if I move this decimal over 1 place, it becomes a 1, right? What's 1 times 5? 5. And then I'm just going to move it back 1. So if I move the decimal back 1, it's just 0.5. Okay? All right, and now I'm going to do what? Yeah, divide by 450. And again, when you're doing this type of division, we're just going to reduce this fraction, okay? So in order to reduce a fraction, if it's 0.5, do yourself a favor and multiply by what? Yeah, because if you can deal with smaller numbers, you want to. 2 times a half is, if you have 2 halves, you have 1. Double 450? Yes. Okay, so now we're going to plug this into our equation. Now, the equation is going to look, well, a bit different. And you can leave your equation like this. I am going to let you leave it like this. 1 over 900e divided by m. Okay, we can leave it like this, but I also want to show you an equivalent form. Okay, why? Well, your answer key might have something different, and this is something else you could see on the PSAT, okay, or SAT. So let's simplify this. What if we don't want a fraction within a fraction? Remember, this means division, right? So this is 1 over 900e. Well, what's 1 over 900 times e? We are going to do that, yeah. So 1 over 900e is the same thing as e over 900, because you multiply the whole number by the top. Okay? Now, this is division. So this is e over 900 divided by m. Now you can use your division rules for fractions, which is, what do you guys say? Heat change flip, multiply by the reciprocal. Great. Okay, so the first one stays the same. You change it to multiply. What's the reciprocal of m? 1 over m. So then you just multiply straight across. E times 1 is e. 900 times m is 900m. And then this is an equivalent equation. These are the same thing. And then again, you don't have to do this. I would accept this, but this might be a easier one to plug into. Okay, you guys can decide. Just be able to recognize both. Okay. All right. So we did step 1, where we're finding k. Step 2 is going to be to answer this question. So they're asking you how much heat energy must be transferred to an aluminum wire with a mass of 0.2 kilograms to raise its temperature to 20 degrees Celsius. Okay, so how much heat has to be applied? So we're going to use our equation. We'll use this one. Find E when the mass is 0.2 kilograms and the temperature is 20 degrees Celsius. All right, so do you guys think you can plug that in and solve it? And you can use either one that you want to. You can use either one. I'm going to use this one. And the back in the final answer is your download. so when you multiplied by 0.2, if you did it this way, remember that when you're multiplying these, you can just do 2 times 20, which is what? 2 times 20 is 40, and then that's because you moved the decimal, just move the decimal back. 4.0 is just 4. And then how do you get e by itself with this guy? Yeah, multiply by 900. So 4 times 900 is 3,600. All right, so then, you guys did it the other way? Yeah.
Oh, that's fine.
Yeah, that's fine. And then this is what you should get. Or if you have 20 equals, if you use t equals e over 900m, okay, then your first step is multiplying 900 by 0.2. So again, what I would do is 900 times 2. So if you double 900, what do you get? 1,800. And then because you have one place, you move it back one place. So it would be 180. So it'd be 20 equals e over 180. And then you'd multiply both sides by that. And again, I would do the 18 times 2. 18 times 2 is 36, and then just put your 2 zeros on. And then don't forget to label with your units. So make sure you put the J for joules, or you can write out the joules. Okay, either one of those are fine. Okay, and then I'm going to give you some time today to work on your homework, your 5.1, day 2.